Hey there everybody, welcome back for another Pre-Calc 11 lesson. We're actually starting a new unit today, which is going to be on solving quadratic equations. We've talked already last unit about quadratic functions, parabolas, all that stuff. And now we're going to look at how we can solve these equations. So remember that a quadratic equation is going to be any equation that has a degree of 2. And remember that a degree refers to the highest order exponent that you have in the function, in the equation. And so the roots of an equation, which are also known as the zeros, are the solutions to the equation. Now, let's put this in terms compared to what we've already been talking about. Take a look at over here on the side here. I've got a function that you can see here. So this function is written as f of x is equal to 2x squared plus 2x minus 12. Now, because it's a function, you can put in any value of x you want, and it will return a value, which we could then plot on the y-axis. So basically, whenever you pick any number you want for x, sub it in, and you'll get an answer for y. So as it is, this function has an infinite possible number of solutions. You can put in anything for x, and you'll get the answer for y, and then you're done. But if this was an equation that we were going to solve, suppose that we set our y value equal to 0. And we have the exact same equation, 2x squared plus 2x minus 12. Now this has a finite set of solutions, okay? In this case, it has exactly 2 solutions. I'm asking myself, when will this function equal 0? That's the same as saying, where is this graph going to return a y value equal to 0? And the y value equal to 0 refers to our x-intercepts. So you can see actually here there are 2 solutions to this equation. I've got zeros or roots. That's a 0 and that's a 0, also known as a root, and because that's where the function will cross the x-axis, or to put it another way, that's where the function is equal to 0. So whenever we're solving, and so it's important to keep in mind the distinction between functions that have infinite solutions and then equations which will have either 0 or 1 or 2 possible solutions. So let's do this. So we're going to solve this equation here. We're going to solve it by graphing, and then we're going to solve it by factoring. So there are 2 possible skills that we have. If we want to solve this by graphing, we need to start with x squared minus 4x plus 3 equal to 0, and we would have to write this in vertex form. And if we can rewrite this in vertex form, then I could sketch the function that that goes with this and then figure out the solutions. So I'm going to just complete the square in order to do that. I'm going to look at just these 2 terms, and I'm going to say, okay, so x squared minus 4x plus something plus 3 is going to equal 0. Now, I remember before that this number here is going to have to be half of the b value squared. So this is half of 4 is, half of negative 4 is negative 2, squared is 4. So I'm going to add 4 there. And then I also have to remember to subtract 4 over here to balance that off. And then now I can write this as a perfect square, which is x minus 2 squared. And then 3 minus 4 is going to be just minus 1. Whoops. And then 3 minus 4 is just going to be minus 1. And that whole thing is equal to 0. So on this graph, I'm going to graph the function, which is f of x is equal to x minus 2 squared minus 1. And I'm going to see what that looks like. Well, minus 2 means shift 2 to the right. Minus 1 is going to make me shift down 1. And so there's my vertex located at 2 minus 1. And then my a value is 1, so I don't need to change my pattern. I'm going to go over 1 and up 1, over 1, up 1, over 2 and up 4 and 4, and here is my graph, and away we go. And so the question is, well, where is this function equal to 0? Well, it's equal to 0 right here and here where we cross the where we cross the x-axis. And so I can see that the answer there is, well, that's going to happen when x is equal to 1 and where it's equal to 3. So I can read those points right off there. That's 3, 0, and that's 1, 0. Okay. So pretty straightforward, although, you know, it can be more work. That was a relatively easy one to complete the square on. Another way to solve these equations is to factor them. Okay, so with factoring, we're going to start with the same function. That's x squared minus 4x plus 3. So we've got x squared minus 4x plus 3 equals 0. And I'm going to factor this out, like we've done a bunch of times before, just see what I get. And so remember that something plus something equals something, and something times something equals something. The two numbers are going to multiply to make 3, and they're going to add to make -4. So the two numbers I have in that case are -1 and -3. -1 and -3. And so this will factor out into x minus 1 times x minus 3 equals 0. Now, hopefully you're already kind of catching on, because it's the same one we solved graphing, that there is a little bit of a pattern starting to emerge here. What I want you to recognize is that for this whole thing here to equal 0, there's two possibilities. Either this left bracket, that could equal 0, or the right bracket could equal 0. If the left bracket equals 0, it doesn't matter what's in the right bracket, because 0 times anything is going to be 0. And so basically what this means is, now either this is 0, so x minus 1 could equal 0, or this is equal to 0, which is say x minus 3 equals 0. Those are two possibilities. Now I need to solve both of these individually. So if x minus 1 equals 0, just add 1 to the other side, plus 1 and plus 1, I get x equals 1. And here, plus 3, I get x equals 3. Now x equal to 1 and x equal to 3, you'll remember those are the exact same solutions that we got previously, right? That we got up here when we did it graphically, that x could equal 1 or 3. Now, we should point out, or I should point out here, that oftentimes students get to this step and they forget this next one. They get to this point and go, oh, okay, x is minus 1 and minus 3. And that's a big no-no, because we need to make it so that this whole term is equal to 0. So x could be plus 1 or x could be plus 3, and then that would make the whole thing 0. So we're going to get, we're just going to do some practice. We're going to practice with the factoring. And then and there's about 4 examples here I want to do. Okay, so when we're solving by factoring, you have to make the right side, or one side, make the right side of the equation equal to 0. That's step 1. You're then going to factor the left side as much as possible, and then you're going to set the binomials equal to 0 and solve. And so we'll do some examples of that right now. So our first one right there, we've got y squared minus 36 equals 0. Well, this is actually a special case, because this is something called difference of squares. We've seen this before. Y squared is a square, and then 36 is a square, and we're subtracting them. I remember that in this special case, this factors into x plus 6 and x minus 6, and so that is equal to 0. So now I've factored it out. I need to set each individual binomial equal to 0. So basically, either x plus 6 equals 0 or x minus 6 equals 0. Well, what does that mean? If x plus 6 equals 0, I'm going to solve for x by minusing 6 from both sides, and I would get x equals -6. And then for this second equation, my second binomial, I'm going to add 6 to both sides, and I get, well, x equals +6. So those are my two solutions. X is either +6 or -6. And I could point out that you could, I guess, just write that as x equals plus or minus 6 if you prefer. That's also just as good. Okay, let's try this next one here. 2x squared minus 11x plus 12. So we're going to, I think we're going to have to do a decomposition here, because this a value is not 1. So to factor it, we'll have to do some decomposition. So I've got something times something equals 2 times 12 is 24. And then something plus something equals 11. So multiply to 24, add up to negative 11. They're going to both be negative, and I think they're going to be negative 3 and negative 8. So negative 3, negative 8. I'm now going to decompose this term into those two. And I don't know if it matters too much, but I'll do it this way. I'll say 2x squared minus 8x minus 3x plus 12 equals 0. And then remember, I'm going to just kind of factor this part, and I'm going to kind of factor that part. And so I can factor out 2x, and that leaves x minus 4. And then over here, I'm going to factor out minus 3, because that's going to leave x minus 4, and this still equals 0. And so that's good, because remember, I got the same terms, binomial terms there. And then I'm going to factor that out completely, and I got x minus 4 times 2x minus 3 equals 0. And so now I need to check both of my binomials. So either x minus 4 equals 0, which just becomes x equals 4, or 2x minus 3 equals 0. And this one's a little bit trickier, so I'll do this one. So I'm going to add 3 to this side, add 3 to that side, and I get 2x equals 3. Then I'm going to divide by 2, and so I get x equals 3 over 2. And those are my two solutions. Okay, maybe we'll do one last one here. X squared minus 3x equals 18. Again, there's only one variable here. It looks a little different because 18 is on the other side, but there's just going to be a finite set of solutions. The first thing I'm going to do is I'm going to move this 18 over to the other side of the equation. I need the whole thing to be set equal to 0. So I've got x squared minus 3x minus 18 equals 0. And now I'm going to factor. So I've got x, let's see, something times something equals something, something plus something equals something. Very technical language, this. So something times something is going to equal negative 18. Something plus something is going to equal negative 3. And so I feel like negative 6 and 3 will fit the bill. And so this factors into x minus 6 times x plus 3 is equal to 0. And again, we have to set each of those binomials equal to 0. So x minus 6 equals 0. That means x could equal 6. Or x plus 3 equals 0. That means x could equal negative 3. And those are my two solutions. Okay, so we've seen a few examples so far. And in each of these cases, we worked out, each time there was two solutions, it worked out great. But you need to be aware that, of course, there are other possibilities. Last year in grade 10, you probably looked at solving linear equations. And linear equations are great because there's always exactly one answer, right? Just always. That's just the way it is. As it turns out with quadratic equations, though, there can be different possibilities. Sometimes there's two answers, just like we just saw. Sometimes there's no answers at all, and sometimes there's exactly one answer, which is a little bit strange. So just to kind of visualize what that might look like, if there are two roots, well, that could be something like this, where I've got like a parabola that kind of goes through, cuts here, and then cuts there, and then takes off. That has two roots. You can see them right there and there. Or it could be something like this. Maybe that's a parabola there. We can see it's got a root there, and it's got a root there. So whether it's inverted or upright or inverted, doesn't matter. It's still possible to have two roots. If you have exactly one root, there's exactly one solution. It is entirely possible that you have a parabola that comes down and literally just touches the x-axis at a single point before taking off and turning back upwards again. And in that case, you would get exactly one root. And again, it's possible to have it inverted and just touch the axis here. And the last case is if we have zero roots. And zero roots is really simply if I have a parabola that just never crosses the x-axis, then it's not going to have any solutions to that equation. It's not going to have any roots. Or I should say, it's not going to have any real solutions. And so we will see that come up from time to time. Okay, so we're going to do 4 more quick examples. Okay, so let's do 4 quick examples here and see how we do. This would be a great time, again, for you to just hit pause on the video and try them out, and then see how you did. So now that you've paused and tried them out, and you're just seeing how you did, I'm going to factor this out right here. 2x squared plus x equals 0. That looks a little different. There's no c term here. That looks like it's going to be more complicated, but in actual fact, it's going to be easier because I'm just going to factor out the x directly. And I'm going to get 2x plus 1 equals 0. And so in this case, I've got the x on its own with the binomial. I don't have the 2 binomials. That's okay. That just means, well, if x equals 0, this whole thing equals 0. So right off the bat, I know that x equal to 0 is a possibility. Okay, and then now let's check the binomial. So 2x plus 1 equals 0. I'm going to subtract 1. Okay, so let's check the binomial. So 2x plus 1 equals 0. I'm going to subtract 1 from each side, and I get 2x equals negative 1. And then I'm going to divide by 2, and so I get x is equal to negative 1/2. And it's probably worth just kind of formalizing our answer here and making it really clear. We've done a bunch of work over there, but it's a bit messy. So I'm going to say x can equal either 0 or negative 1/2. And those are my 2 possible solutions. Now the nice thing about doing these equations is when you get an answer, you could always check. Like, you could know whether or not it is the right answer, because all you have to do is feed those numbers back into the original equation. So for example, imagine x equals 0. I'm going to feed 0 back into the equation for x, and I would get 2 times 0 squared plus 0 equals 0. Does that make sense? Yeah, 0 plus 0, that does equal 0, so I know I'm good. What about x equal to negative 1/2? Well, 2 times negative 1/2 squared plus negative 1/2. Does that equal 0? Well, negative 1/2 squared, the negative is going to disappear, and 1/2 times 1/2 is actually a quarter. So this is 2 times a quarter. So that's 2 over 4. And then I'm going to add to it negative 1/2 minus 1/2. Does that equal 0? Well, 2 quarters is 1/2. So 1/2 minus 1/2 is 0, and so I know those are the right answers. So like I said, you can always check whenever you're done, whenever you've got your answers, and you'll find out whether or not they actually are solutions. Okay, a couple more. So I'm going to rewrite this. I'm going to subtract 30 from both sides just to get everything over on the left. So x squared plus 7x minus 30 equals 0. And so I'm looking for 2 numbers that multiply to minus 30, but that add up to 7. And so I guess I've got minus 10 and 3. And so this factors into x minus 10 times x plus 3 equals 0. And so now either x minus 10 equals 0, which is to say x equals 10, or x plus 3 equals 0, which is to say x equals negative 3. So I can just say x equals negative 3 or 10. And I'll leave the checking to you. All right, 2 more. I've got 2x squared minus 2x minus 12. Now, at first, I'm worried I'm going to have to do decomposition here, but then I noticed that I can actually factor out 2 from this whole thing. Let's see what happens there. 2x squared minus x minus 6 equals 0. When I can factor out a 2, and if this is an equation equal to 0, well, then I could just divide both sides by 2. Divide by 2, divide by 2. And I can't divide by 0, but 0 divided by any number, that is still just 0. So this essentially cancels out, and then it's gone, and I don't have to worry about it anymore. So if you can ever factor anything out off the bat, definitely do that. Factoring is your friend. Okay, let's factor more. So 2 numbers that are going to multiply to negative 6, but are going to add to negative 1 are negative 3 and 2. So I'm going to factor that out into x minus 3 and x plus 2 equals 0. So x minus 3 equals 0, which means x equals 3. And x plus 2 equals 0, which means x equals negative 2. So my solution is x equals negative 2 and 3. All right, last but not least. So this one looks pretty ugly, but we need to recognize that it's actually not it's not any different than what we did before. It's just the starting point is a little bit messy. So I need everything over to the left side, and what I'm gonna do is I'm gonna expand out and collect terms first, and then I'm gonna pile everything over the left, and then I'm gonna solve. So I'm just gonna expand this in here by multiplying across and get 3x squared minus 12x equals, I'll do the same thing over on the other side here, 2x plus 2 plus 3. And then now I'm going to move everything over to the other side. So I am going to subtract 2x, and then I'll just minus 5 from this side. So minus 2x and minus 5. Let's do it all in one go. So these are gone, and that's gone. And I get 3x squared minus 14x minus 5 equals 0. Now in this case, I can't factor out that 3, so I'm going to have to do decomposition. Can't get away. Remember that this is something times something is going to equal 3 times minus 5, which is negative 15. And then something plus something is going to equal negative 14. And I feel like that is 1 and negative 15. So I'll decompose this into 3x squared minus 15x plus x minus 5 equals 0. And then continuing along here, I'll just kind of factor there and there. And so I can take out a factor of 3x times x minus 5 plus, no need to factor anything, so just x minus 5. Remember that there's like a factor of 1 there, I guess, if that helps. And so I'll go up here and factor it again and say x minus 5 times 3x plus 1 equals 0. And then so now I'll solve my two binomials. And so x minus 5 equals 0. So x equals 5. And 3x plus 1 equals 0, which when I solve that, I get x equals negative 1/3. So x is going to equal negative 1/3 and 5. Okay, so that's it for solving equations by graphing and by factoring.